Hey everyone, thanks for joining us today. We're actually in our new library space at Baker's Place, which we have just opened, and they're still getting all the furniture in. So we're in a little bit of a makeshift studio, which is exciting. But today we're going to be talking about how we can use whole trees in our building environments for a lot of different uses, for commercial, for residential, for multifamily. And Amelia has about a 15 to 20-minute presentation for us. And then we will open it up to my questions, which I have a lot. And we'll also open up to your questions. But thanks for joining, and let's get rolling.
Great, thanks. My name's Amelia Baxter. I'm CEO and co-founder of Whole Trees Structures, and I'm here to talk about what our company considers the original mass timber. For almost 18 years, my company's been scaling trees to structural markets and bringing prosperity between forests and people. I'm going to spend a little time on the history and mission of my company, then a little bit about why solid structural timber and how we thought we'd be able to find new markets for what we consider a brilliant engineered material. And then I'm going to talk about the times we've found in our experience when the greenest of structural timber makes sense in development projects. If there's time later, I'll briefly touch on our recent success at the Venice Biennale. We are currently in a shared exhibit with MIT's School of Architecture and Design, and there's some exciting future looking going on in our exhibit.
Cool.
So Whole Tree Structures scales a seemingly complex, bespoke structural product, solid timber, to markets drawn to its beauty and economy in the built environment. We apply proprietary tech and know-how from sales systems to engineering to supply chain networks and fabrication. And we are the singular national supplier of solid structural timber to modern building design and construction. As many of you likely know, mass timber is considered a structural product made of solid engineered wood, massive enough to withstand greater than 1 hour fire ratings. And it's produced via a scaled fabrication process that can reliably deliver carbon sequestering timber systems. Whole Trees brings to the built environment the joy of the original mass timber, trees, and the awe and the delight of original mass timber fabrication facility, forests. Our company unites what we consider a brilliant naturally engineered wood product, trees, to new commercial construction markets in the form of solid structural timber, SST, both round and sawn. Of all mass timber products, SST has the lowest CapEx entry cost for fabricators, highest prices paid to foresters, and least carbon emissions. The industry understands that forest could be a global climate solution, but they need markets that pay more for trees. And solid structural timber is the highest value use for trees, but the industry is not designed for scale. A little more on that point. Markets are growing for structural timber. The Neutral Project's an excellent example of that, but are limited to glued lumber products, which is called engineered wood products. These decarbonize our built environment at scale, and that's fantastic. They don't necessarily allow for the optimal forest management or forestry profits. They often require homogeneous economies of scale and timber inputs. They often exclude diverse forests and regional traceability, and they tend to pay timber prices that are a bit lower to manage forests for optimal carbon sequestration. Solid structural timber at scale requires innovation, software-enhanced inventory solutions that also guide sales, engineering and product management solutions teams, and regional fabrication facilities. Oops. So Whole Trees is scaling solid structural timber to commercial construction with new products and digital technologies. We encourage carbon smart forestry by linking decentralized forest and varied species to a growing demand for structural timber. What is the secret sauce that brings solid timber to its rightful place in the mass timber family of production? It's information, mechanical properties, varied geometries, region and availability, At Whole Trees, we data mine trees and then build with them in place of steel. We are a software-enabled hub between forest, timber cruiser, inventory yard, digital measurements, BIM design, and solid structural timber products.
Can I ask you, sorry to interrupt,
Yeah.
what is timber cruiser?
A timber cruiser is the name of a trained forestry professional that knows how to walk forests and assess economic value, species biodiversity, and develops harvest and management plans,
Okay.
as well as select trees for harvest.
Sounds like a fun job.
It does.
Great gig.
Whole Trees reaches timber markets in a wide array of large niche verticals. It's our flexible as needed inventory solutions that allow us to source diverse regional species based on the design intent and structural needs of a product, and then deliver with lead times that are equal to that of steel and often beat glue laminated delivery timelines. Here's an example of what we sell and what constitutes solid structural timber. We prioritize offering the architects within these diverse market verticals three things: the digital specification tools they require, such as 3D models for BIM design, expertise in code and engineering solutions, and then an exceptional project management ethos as we lace together the traceable supply chains and quality-controlled fabrication of solid structural timber products. We're a solutions provider, and we bring owners, architects, and building users closer to regional forests, both by sourcing product for them and also bringing biophilia into the built environment. We sell design and engineering services, and we assemble trusses, beams, columns, and biophilic trees. I'll talk a little more about this Revit model in a bit. This is a map of our revenue to date by region. We founded in the Midwest, so we have a greater impact there to date, and we're now growing markets for product nationwide and in Canada. We utilize 2 in-house production facilities, one in Wisconsin and one in Maine, and multiple strategic fabrication partners. We consider our company as the only example of a scaled solid structural timber fabricator, but our competitors are alternative structural products like steel or engineered wood products, glued products, as well as the disparate SST fabricators nationwide. They may not be as scaled or as in tune to the digital needs of the design community, but there are those who can do what we do, at least in a less diverse and I think maybe less biophilic way. Our products have a price point equal to that of glue laminated structural systems. We also meet the price of heavily loaded steel columns, but we are definitely 35 to 50% more expensive than the lightest gauge steel when it comes to spanning space. We are not the first to use solid timber in commercial structure, but we are the first to apply digital tools and a new vision for modern construction in order to rebrand solid timber as a sophisticated member of the mass timber family. This is an award-winning renovation, an historic 1852 mill in Lewiston, Maine, and the building is a multifaceted structure with a pub, production brewery, museum, and offices. It's an exquisite example of historic use of solid structural timber, both round and sawn, and these are likely white pine from Maine's older growth forests.
Can I ask a question?
Yeah.
How does this image look different than some of the stuff you're doing? Is it just that they're sawing it down to have it be the same dimension?
Yeah, those are lathed, something we do.
Okay.
And it was the question of why they lathed at that time, I don't know.
Okay.
It's a great question. I wonder that myself. But that's why.
Interesting.
And it's and lathing is works and creates a little bit more of a clean aesthetic. I like it very.
Because then it has this kind of uniform nature. Where they'll just...
Correct. It's a uniform. Yep. It's a whole different aesthetic look.
Yeah.
We're a fan. But a different aesthetic look, I suppose, would be this project at Children's Museum. By applying intelligent systems to forest inventories, timber logistics, grading, fabrication, and the specification process itself, the forest products industry is able to scale structural round timber and solid timber, square sawn into commercial construction allowing trees to take their rightful place as the original mass timber. This is a scaled rendering of a 2023 Children's Museum in Wisconsin, where structural round timber served as the multi-story mass timber structural system. The architects, which were in Manhattan, downloads our BIM families of trusses, as well as our 3D scans of the actual tree columns, which were sourced from both Wisconsin and Maine. The truss systems were sourced from a very carbon smart forestry company, Port Blakely in Washington and Oregon. These are Douglas fir. So very promptly after completing this project in 2023, it won the Outstanding Structure of the Year Award from the National Council of Structural Engineering Associations, kind of pointing to the fact that this is an exciting use of a new material, and its time has come. Unmilled timber is 50% stronger than milled lumber of the same diameter, with the same cross-sectional properties, as long as the diameter has the same cross-sectional properties. Another way to say this is that the largest milled timber cut from a round will only have 17 to 33% the strength of the original log. So that's a great deal of optimized strength that we lose. With round timber, the external tensile fibers remain intact. But when milling logs into sawn timbers and lumber, those fibers are sawn off and interrupted in order to square up the wood. One of this particular graph comes from the USDA Forest Products Laboratory here in Madison, Wisconsin, and there are decades of general reports and research around the strength of raw unmilled timber.
So just a quick question on this. If we're using, let's just say, whole trees like you are, where you have this in diagram B, you're saying that you have, on average, roughly 70% increase in strength compared to doing the more dimensional lumber?
You do in reality. That said, the grading techniques of round timber are still antiquated. They require visual grading versus machine stress rated grading, which is available for milled wood and glulam. Until we have an MSR grade for round timber, we can't give it the strength it deserves per code. This means that the footprint of our round columns tends to be wider by 1 to 4 inches, depending on weight, than a sawn timber or glulam.
And that's just because there's more fiber in the scenario with the round timber?
There's more fiber, and engineers are unable to give it the design values it deserves because of we have to use published design values for a wide range of species that were developed in the 1930s. There's a mechanized opportunity now to prove the highest mechanical properties in the fabrication facility, but round timber doesn't have that yet. I've co-published a paper with Michaela Harms in Structure Magazine on how to get there, and it just requires time and investment.
Okay, interesting.
Yeah. In this graphic, we see the processing chain for engineered timber product. Structural round and square timber omits the 3 most energy-intensive steps, not to mention the use of toxic adhesives in the process. By data mining the tree at the landing and diverting valuable structural material to fabrication facilities, we bring value directly to foresters, paying 2 to 5 times that of other available markets for trees.
So just so if we can stay on this graph for a second, you're basically taking where we see here in logs.
Correct.
And you're using that. What we're doing is we're taking I see CLT and glulam up on the top.
Yeah.
So really our logs go from logs all the way through CLT to glulam, just to give people context of the 2 different types of wood we're talking about here.
And every one of these is fantastic for forest products industry. We are not anti-cross-laminated timber. We're thrilled about the mass timber movement. We're just excited to be a driving, growing edge of the movement, saying, hey, let's go even further.
Really just further back in the supply chain is what
further back in the supply chain by understanding information better. We created the industry's first EPD, the Environmental Product Declaration for region-specific structural round timber. This slide shows the results of our recently published EPD compared to glulam and cross-laminated timber. As you can see, glulam, EPDs use the unit global warming potential, which is kilograms of CO2 equivalent per meter cubed of product. And even compared to glulam, we are delightfully lower in terms of the cradle to gate amount of energy required and carbon emitted. Especially now, this is why we're also a big fan of glulam timber. We're all in the forest products industry much cleaner, greener than any kind of steel.
Yeah, I mean, look at that. It's like we're 1/10 of what hot rolled
Correct.
steel is, but then you guys go even
We
farther.
go a little further. I mean, we're again huge fans of mass timber
And the
of all forms.
reason for this, just to give folks context, is with glulam, you're going through some additional really engineering and manufacturing processes that would really input more carbon dioxide into the atmosphere because you're having to run all the timber through these manufacturing facilities.
It's part of that. It's also the shipping from a wide range of a timber basket and then transporting them all to scaled fabrication facilities that then mill and then transporting the milling over to a fabrication facility that laminates and then shipping to a project. This one, to point out, it's sourced from British Columbia, the glulam timber. Ours is sourced from Wisconsin. So there's something to be said for the energy saved in regional fabrication, and there's something to be said for the energy saved in the milling, the gluing back together, and then the adhesives and what are required to make the adhesives and bring them to the fabrication
So
facility.
the disparity might be a little bit less of a gap if you guys compared maybe like Minnesota or Wisconsin-based manufacturer.
Yes.
Versus a British one.
Yes, we have a fabrication. We have a similar EPD in Maine, and then there's Nordique that's fabricating just above the Maine border in glulam.
Yeah.
And that would be a different study.
Yeah.
There's still all the other inputs to glulam, but yes,
Sure.
there does data changes given every
So then glulam's probably a little bit less on the carbon dioxide for that one.
Yes.
Okay.
Yes, and they're similar. We actually will get to talk a little more about it when I show you the vanilla project results.
Oh, sweet.
So round timbers fall under building codes types 2 through 5 as complete structural systems. They can also be, for type 2, they're roofing systems above 20 feet, but this is a grocery store in Madison, just across the street from Baker Place, that obtained a variance to use round timber columns in type 2B. Normally, a column would need to be made out of non-combustible material in this type of construction, but getting a variance like this is possible because of round timber's fire rating. Fire marshals often say that they'd prefer to enter a burning round timber or heavy timber building than they would a steel building. Wood chars and creates an outer shield that protects the internal structure for longer. Depending on the diameter, round timber could have a 1 to 5 hour fire rating. This is the McCormick Place, a fire in 1967 in Chicago, where we see steel that is melted and draped itself over a still structurally applicable beam.
Did you talk to the fire marshal in Madison about that?
Yes, we did. So that was back in 2015.
Oh, really?
So to know whether it's the same one, we can swap stories.
It's not. The new one's not as favorable to mass timber.
Well, that's interesting. Maybe we can bring them a massive load of data.
Yeah.
SRT providers bring the concept of round timber into modern commercial construction and develop ways to span wider spaces, much like glulam beams can. So rather than breaking the timber apart and putting it back together, structural round timber commercial products can complement in their natural form other laminated timber products. This is a junior high school near Portland, Oregon, where our columns are paired with glue laminated beams and nail laminated timber ceilings. In this section, I want to talk a bit about what we've learned in nearly 2 decades about when solid structural timber makes sense for development projects. I'm also going to show you some examples we've encountered of some of these scenarios. So I'm not a developer, you are. And having spent time both selling to development projects, losing the opportunity to commit to provide to developers, and talking to people like yourself, I found that these are the times when solid structural timber makes sense so far. It's when a project has a keystone investor seeking differentiation. When a project aligns itself with carbon smart regional supply chains, when a project sets goals for optimal carbon footprint and EPD stats, when it commits to a timber column system already, if it's already committed, then we're very comparable. When it wants the visceral impact and aesthetic patina of solid timber, what you see on the back of this slide is a historic building in Milwaukee that was renovated for mixed use residential development. And of course, when one can charge higher rents due to sustainability and aesthetics, one can spend a bit more on its structural system, these things, you know. So a few examples. When a Keystone investor seeks brand differentiation, this is the Festival of Foods grocery store I mentioned.
Yeah.
And there was within the full residential office and commercial development, a Keystone client that had never had a grocery store in an urban setting. They wanted to appeal to the perhaps you could say progressive nature of downtown Madison, and they asked for and approved the structural round timber system within their grocery store. Also alignment with carbon smart supply chains. Trees can be regionally sourced more reliably with more traceability than the inputs for glulam engineered wood products. So understanding this, Lever Architects designed a net zero carbon design, drawing on Whole Tree's relationship with a carbon accredited forest in Washington State. This project has not yet progressed beyond design.
Let's talk about that for one sec if we go back to that
bet.
one. So for this project, you're using
Sawn heavy timber.
Sawn heavy timber from Port Blakely?
Yes.
And why are you picking Port Blakely?
Because they're our partner. We trust them. We love the way they forest Doug fir. A lot of times Douglas fir is a homogenized agricultural product that doesn't necessarily get managed for maximum carbon optimization of the forest. It gets cut down too soon to allow the trees to reach the size in which they can sequester as much carbon as possible. Port Blakely commits to longer rotations across all of its forests and has 10,000 acres that are accredited carbon forest for allowing rotations as long as 60 to 65 years. So we trust them. And we're brand aligned, and we love Port Blakely.
Because my understanding is we've done some discussions with Port Blakely.
Love to hear more about that.
Most of these forests where we're getting our mass timber from, they're cutting at like 35 to 45 years on average.
Yes.
And just so people know what we're talking about here, we're talking about how long the tree, whether it's Douglas fir or different species, stays in the forest before we cut it down.
Correct.
And use it. And so what Port Blakely is committed to is it's more efficient, right? If we use another 10, 15 years.
It's more carbon efficient.
Yeah. Not necessarily cost effective. Right. Yeah. It's not economic per se for the forester, but if we're looking at it through the carbon lens, the trees take in the maximum amount of carbon in those last 15 years.
Correct.
And so you're saying that for this project, the reason why it might be more sustainable than, let's just say, if you go to KLH or Stora Enso and source wood from them, is because not only is it local, but it's also a longer rotation cycle.
Yes, correct.
Okay. Interesting.
It's a very, if we could grow, there's some great studies on if we could grow to maximum optimized carbon sequestration, most of our Douglas fir forest in the Pacific Northwest, there'd be a great deal more carbon sequestered each year. It would be such a smart solution. And yet nobody requires forestry companies to wait that long to cut. And so the maximum economic cut rate is 35 to 42 years.
Is there any difference that we see in like fiber quality where you're getting more strength, especially if you're using sawn heavy timber?
Yes, there's a great studies. There's great studies, multiple, around how older fibers have stronger strength values. Now that's it's a ways down the line to get to that and bring that into a building. It's doable, but it's sort of right now, even this project is utilizing current state machine stress rated grading and a very specific set of mechanical properties. That's
okay. So you're not going to be able to, let's just say if you go from 40 to 60 rotation cycle, be able to charge more for the, like, let's just say A grade lumber that you're getting at 60 years versus the B grade lumber that you would be getting at 40.
Not yet.
Okay.
Again, it's an issue of optimizing or advanced grading procedures. So there's ways to do it.
Yeah.
But first, the markets have to move quite a ways to demand a certain level of forestry, and then we could start bringing in grading to get an even better quality.
And do you think if we did that, that it would then incentivize the forester economically to lengthen the rotation cycles?
That is Port Blakely's hypothesis. Yes, that if we can show markets that pay more for trees and value solid structural timber from better forests, then absolutely.
Hmm.
We've kind of built out an economic model with Port Blakely and how they could sell enough higher priced trees to the right structural um, jobs, projects
Hmm.
to bring the cost of management up to meet what that needs to be to also be sustainable.
Yeah, interesting.
It is.
I digress.
That's great. So I'm taking a risk here by jumping into these slides because to really answer all the questions you have,
Yeah.
we should bring together with Paul Drace.
Yeah.
He was our director of sales. He's a structurally trained engineer, and he's joined a company near his home in Idaho, which is fantastic. But I'd love to bring us together to share these slides. So don't go too deep for me.
Okay.
I dove in though to all of his data, which was enormous, massive spreadsheets, what he did for this project. So about 18 months ago, Holtrees asked the Neutral Project for the opportunity to review a current project of theirs at that time, the Vanilla Project, and compare carbon footprint and the impact on layouts when Holtrees brought Douglas fir from Port Blakely into this project. Vanilla was designed, if I get this right, because I haven't run this by him yet. Okay. So I'm just diving in.
Go for it.
Vanilla was designed with cross-laminated timber floors and cold form steel framing for its structural wall system. So what you see here is from what we pulled from what we were working on in the model. Our team, which was led by Paul Drace, did an in-depth structural analysis on the CSF and created an alternate system of Douglas fir framing sourced from the Port Blakely accredited carbon forest. In fact, Paul elected to propose both a 60-minute fire-rated wood-framed wall and a 120-minute rated wall, and he has two versions of material takeoffs of all the CSF and all of the timber required to structurally replace CSF for 60-minute fire rating, 120-minute fire rating. And we utilize a published EPD on milled softwoods sourced in the Pacific Northwest and compared it to a published EPD for CFS studs. Here are the comparisons of the two systems for the 60 and the 120-minute wood frame systems. So global warming potential, again, for softwood framing system, total 28.4, CFS studs 364. And then for 120, we go up a little bit because we're using thicker, more timber, but still quite strong. So the final summary here, and again, I look forward to getting you and Paul and myself together, is that building with Douglas fir would be 10.1% of the global warming potential of CSF framing. However, there's an impact to floor plan. The vertical studs and CSF as designed were 6 inches deep, and the way we had to make it work with this, the assumptions we built were 10 by 10 vertical studs for 120-minute. And that created a 20% heavier structural system, which tells me that we would need to be brought in as early in the design phase as possible, just like all kinds of mass timber need that, to make the different constraints of timber work for the use plan.
Yeah. And I think, I mean, that was the main issue was I think we were in like construction documentation.
This was sort of a brain teaser.
Yeah, a brainstorm.
You were great. I was very grateful to get a chance to study the two.
Yeah, no, I love this because what we're looking at, because I think a lot of people, maybe if you're familiar with Neutral, the vanilla system that we're utilizing is going to be a really componentized system that we start using on all of our low-rise projects. So the idea is the next one that we build, which hopefully will be next year, we start figuring out how we can use kind of componentized wood framing.
Yeah, and when exactly?
CFS just made the most sense at the time when we were designing it.
Of course.
But the idea is that we want it to be a full wood structure, mostly due to carbon, but also due to some other constraints.
Yeah. And you achieved that with Baker Place, where we are, more wood.
Yeah, for sure.
I know.
Yeah.
And so it's really exciting. You guys keep pushing where we go and making it work with the numbers. In the interest of time, I'll move just through one more, which is we were given the opportunity to re-engineer a hypothetical research building on the UMaine Orono campus from a glulam and CLT system to one of round timber, hemlock and maple columns. This is a fun visual of how our BIM families alone transform the look and feel of a design process while also communicating the comparison study on which we embarked. So we were utilizing the Revit model created by Simon's Architects out of Portland, Maine, working with Thornton Tomasetti out of Portland, Maine. and we took 3D scans of conifers and replaced glulam BIM objects. We took 3D scans of branching ash representing sugar maples in the atrium, because we had those branching scans. And then all steel connections are engineered and priced to match those of the glulam scenario. When we did our EPT, we again reached and we were shipping from 75 miles from our factory in Maine to Orno. Whereas glulam, they were specifying and engineering with Douglas Fir from British Columbia for this project. And then cross-laminated timber here is this would continue to be the ceiling and floor system.
Yeah.
So
really your system replaces glulam. It doesn't replace it doesn't replace the CLT.
Yep.
Or NLT.
That's correct. So our comparison was we took 2022 SRT estimates and we compared them to 2020 glulam estimates with 2 years of escalation assumptions, very close. Plus, we were, we were able to say that approximately 70% of contract gross revenues would stay in Maine, and this was a very Maine-centered project. And very little, if any, contract revenue stays in Maine for the glulam estimate. And this is sort of where we landed on that hypothetical research.
And is that why the shipping is 1/10 the price for your quote? Because you guys are hyper local?
Okay. Yeah. I mean, British Columbia and Ashland, Maine.
Yeah, it's like halfway across the world.
Yeah. And so I'll pause if you'd like to chat more. This last section was on what we just came home from doing in the Venice Biennale, the Architectural Biennale. And this exhibit will be there for the length of the Biennale through November.
Okay. Yeah, maybe we can circle back to at the end of the Biennale.
If there's time, yeah.
But yeah, we have one question in the chat, which is any example of projects in California addressing the seismic implications? I'm assuming that would be
quite a few.
Probably, yeah, difficult.
No.
Oh, okay.
This is heavy timber construction, so we follow the same code issues as mass timber.
Yeah.
And so what we have to study, and we work with KPFF. Seattle is one of our go-tos on the West Coast. And for 2 structural projects at the San Diego Zoo Safari Park, one is a 3-story resort hospitality type restaurant and VIP lounge surrounded by the safari park. So that was just getting completed. And that was also a KPFF San Diego. All it requires is that you apply heavy timber code issues and engineering techniques to a sophisticated analysis of steel connection design. And it's the same as mass timber.
But is this high rise or low rise?
3-story. It's all low rise. Okay. Thank you. Okay. If that's we can't wait to do high rise.
Yeah. Okay.
But it'll be handled in exactly the same way as you would a mass timber glue laminated column with sophisticated steel connections. And so for us, that has not been an issue. We also have multiple school projects in and around Seattle and Portland. So that's the same seismic issues. But we have quite a bit of experience with that. All low rise.
Okay. Yeah. Because I know we've done some studies of doing mid-rise in San Francisco, and it's pretty difficult. Right now, if the persons who asked that question still listening, I would encourage you to go to it's UC La Jolla or UC San Diego. They're doing a shake table test.
Oh, great.
With a 10-story glulam and CLT structure. Which they got done with the first round last year. They're doing another one this year. And we're going to need to see that data, I think, before we are able to get approval for mid-rise or high-rise.
That makes sense.
Yeah.
And our business model will be addressing, as you all probably know, 75% of commercial construction is low-rise.
Right.
And so our business model is to address as many applications as possible in low rise while proving and pointing the direction towards mid rise, and then finding the right partners to do it.
Yeah.
I'm curious though, and I'll be asking KPFF whether the shake tests for glue laminated columns can easily
be
translate.
Yeah.
Yeah. I have a hunch that it can, because they have similar performance properties. They won't be the same sizes. Like I said, solid structural timber needs to have a slightly wider footprint, but wider as in bigger dimension, but I'll look forward to learning.
Yeah, that was one question I have is who's kind of your main customer right now as far as like product type, not necessarily like, do they have a big investor that wants us to do whole tree structures, but is it like schools? Is it multifamily? Is it homes?
Well, yeah, I'm thrilled. It's not residential, and I'm thrilled to say we have a wide market vertical, a wide group of market verticals. So we are in K through 12 and university. We're doing office buildings. We also do a lot of zoos and like the structural work for buildings and infrastructure for zoos. We've worked with tribal interpretive centers. And then we work quite a bit with parkitecture. So the structures and infrastructure required by our parks.
Okay.
So it really is across a wide group.
Yeah.
And that makes me feel great because it kind of protects us a little bit from recession. We're very diversified.
Yeah.
We get to do a couple engineered multi-story things or double story a year, but mostly it's still single story. And we keep every once in a while, we get ourselves into another 2-story and looking for 3-story opportunities.
Have you ever done a single family home?
We started as a company in residential, and my co-founder, Roald Gunderson, was demonstrating that this material coming out of managed forests in Wisconsin was beautiful and very strong. And he was reading the general data reports from the USDA Forest Products Laboratory here and learning about some of the stuff I mentioned earlier in the presentation about how strong round timber is. So he was building agricultural buildings and then residences. And we founded Whole Trees when we received, I think, 3 residential general contracts in 1 year and needed to turn into a company for that. And then my interest in Whole Trees from the very start was, okay, we're going to do a company here. Let's show all the different markets we think are going to grow towards this material as architects and owners get greener and start to understand.
And so those first 3 homes you guys finished?
Oh yeah, we did quite a few more.
Oh,
so the first 3 years of our existence was residential and SBIR innovation grants working with the Forest Products Lab to move towards commercial. And we got our first 2 commercial projects in 2010, and the business model was so much smarter and so much more exciting for us to just sell to architects and provide the wisdom, the tools, the expertise to bring timber into the structure. Yeah. And so we started to move away from residential.
Yeah, that's cool.
It's also a smarter material in commercial. Residential, it looks gorgeous, and our website has residential examples in the portfolio, but the material is very strong and needs to be holding up heavier loads and managing wider spans than residential.
Of material.
But it looks gorgeous.
But it looks probably really nice.
Yeah, the residences are beautiful. We'll take a residentials now, but we always say, "Are you sure?"
Yeah, yeah. Interesting. Okay, we have another question. Does checking affect the connections more in round timber? And do you have to do extra planning for that? Do you use jack plates? Well, I'll let you answer that question before we go to the next one.
Great. Okay. Yeah, I was just reading ahead. So again, the Forest Products Lab here in town has great studies on when does checking affect structural round and solid timber and engineered systems. Yep. And as long as you have visually graded that material to fit a grade A or a grade B or 1 or 2, I should say, you've already ascertained that for round timber, that the fibers are not running too much twist, that they're running in a very specific direction. So with round timber, they will check in a certain way, and that won't affect structure. It's shown that a check can run 60% through the dimensions of the round before affecting any structural application. So checking is not a problem as long as we're utilizing grading techniques and third-party grading, which we are. Now, the connections, though, we do work with our engineers on the best connections for intersecting wood fiber. Wood fiber shifts a little bit. And so we use connections with multi bolts or fields of screws when that makes sense. We specialize in cord, very heavily loaded base connections to manage structure and axial loads while also allowing for any checking that may occur. So the answer is it's very doable as long as it's considered from the start in terms of what connection systems we're going to use. In terms of jack plates and log home industry,
Yeah, here, let me ask
I
you a
don't, oh
question
yeah,
just so
right.
everyone hears it. Do you use jack plates and other similar connections that log homes would use?
I don't know. We are so different from the log home industry. And I don't know what jack plates are. I'm sure my fabrication VPs and managers would. But we've always tried very hard to say timber belongs in markets that aren't log homes. It functions better when it's holding axial load vertically and not lining up horizontally to receive load. And so it might be a bias against the log home industry for whole trees
Yeah.
that leaves a blank in my knowledge as to what a jack plate is. I don't know if it's
Yeah.
a knife plate or if it's a knife plate. Yes, we use those.
Yeah. Okay. Interesting. Yeah.
But I'll go find out.
That is a good point because it's like if you look at a log home, you're basically way underutilizing the fiber and all that wood because you're just basically making a very, very strong wall
Yes.
that isn't very useful.
Agreed. And
Or
there's
does it have a
nothing,
very high R value?
and nothing wrong with log homes at all. They also create higher value markets for forested communities. Like log homes are great.
Yeah.
They're just not whole trees. Whole
Well,
trees is about the structural capacity of timber and commercials.
and the efficiency of timber.
Yeah.
Like we should use our natural resources in an efficient way.
We should use our natural resources in sustainable ways by finding all the markets, including log homes. I'm very inclusive of anything that brings timber from well-managed forests into fabrication.
Yeah.
So I'm pro log home.
I think I would be pro log home if we could figure out maybe a more efficient way to do it.
Okay, great.
And if all forests were sustainably harvested.
I'll let you be the one who
I won't die on that hill. Okay, so tell us just for like maybe the last 2 minutes here what you guys are doing in Venice. And then we'll probably have to wrap up.
You got it. So in February 2025, we announced a collaboration with researchers from the MIT School of Architecture and Planning and their digital structures group. And we were building out, well, we built out a whole semester to study, but the exhibit showcases how combining advanced LiDAR and photogrammetry with computational algorithms could effectively streamline the use of structural round timber for the design world. Tree Form is the name of the exhibit. It's a multi-pronged project exploring the potential for computational intelligence, nature, and sustainable architecture. So in the interest of time, I'll just share that the kind of the assignment or the vision of the Biennale this year was proposed by its lead curator, Carlo Ratti, and it's looking to create a better alliance between natural and artificial systems in all the different countries and architects and universities that showed up were answering that call in what they propose. And some of the images here are just images we took when we were there of different exhibits. And then we, in Tree Form, integrated emerging 3D scanning, algorithmic design, and then automated engineering analysis techniques being developed at MIT to transform irregular, underutilized wood into high-performance architectural structures. The message of both the MIT School of Architecture's design and planning department is that, and Whole Trees, is that technology will enable structural round timber as a scalable, sustainable material. We worked very quickly, both with MIT's researchers and the architectural firm KVA MATX. And we had to kick off the project very quickly, starting in January. We needed to get our exhibit on a container to Venice by March. We worked with their digital toolkit to run our 3D scans taken in Maine. So what is going on here is trees were harvested in Maine. We scanned those trees. We ran them through a structural model to help define the exhibit, the 12-foot exhibit we were sending. And at the same time, KVA MATX, the architecture firm, did a larger hypothetical workflow for a 4-story building. They scanned many twigs, created digital twins library, ran that library through a computational analysis toolkit developed by MIT to create best use, best placement of all of the timbers you see on this 4-story building. So this is in in theory, in digital, a viable structural model for 4 stories. And then the public unveiling was with our partners at an exhibition called Climate Work, Unworlding the Planet. And it was very well received. And it came with a video, which we've said we'll put up on the
Yeah, we'll have to
line
put in the
notes.
show notes if you want to watch it, just because it's probably going to be leggy for you on
Yeah.
your screen. So,
But it's a wonderful video. It's very inspired. It tells the story of where the vision of this exhibit is pointing us towards. And it helps Whole Trees think about how these digital tools will help us manage larger and larger inventories across many different forests.
can I buy one of those models from you? That's beautiful.
That was KVA MATX.
Wow.
So they really captured kind of the dream world of where this material should go. And it was such a hit at the exhibition. It's gotten great press. It really moved people as they came through the exhibit. We were very clearly engaging the audiences. She and their firm did a great job.
Yeah, that's really cool. I'd love one of those in our lobby. Well, where can people find you if you want to check out more about Whole Trees or you want to look at the Vienna project?
Yeah, the wholetrees.com. And on our news section, there's a blog tab that has a whole Venice journey to Venice long form article sharing all the steps and stages, what we hoped to learn, who our partners were. And of course, you could find us in Venice. And I highly encourage that everybody go.
Book a plane ticket, go to Venice.
Although that's
Check
the
it out.
carbon footprints is
Yeah.
arguable, but
Yeah.
it is exciting.
Maybe watch the video. That'd be better.
There you go.
Well, thank you so much for joining. This was really educational. And thank you everyone for coming and taking your lunch break with us. And we'll see you next time on Neutral Webinar.
Thanks.
Thanks.